This learning target is about the relationship between temperature and volume, but before we explore it, let's remind ourselves quickly of the units for the three properties of gases that we've learned to measure this unit: pressure, temperature, and volume. Pressure, the units are ATM and mmHg. For temperature, we've learned three units: Kelvin, degrees Fahrenheit, and degrees Celsius. And for volume, the three we're going to encounter the most: milliliters, liters, and centimeters cubed. So the combined gas law, if we remind ourselves, is P1 V1 over T1 equals P2 V2 over T2. Since we're dealing with just temperature and volume in this learning target, we can essentially get rid of pressure, leaving us with the relationship for volume and temperature of V1 over T1 equals V2 over T2. Volume and temperature, how are they related? They are directly related. So that means they move in the same direction. If temperature goes up, then volume is going to increase as well. If we looked at that on a graph quickly, it would have a positive slope representing a direct relationship. If instead temperature decreased, then volume would also decrease. So with that knowledge, let's go ahead and apply this to a few problems. So number one asks, what will happen to the size of a volleyball if you put it in a sauna? So we always have to think about what is changing in these problems. Well, we have a volleyball, and we're putting it into a sauna. Well, a sauna, we know, is really hot. The temperature is going up. Okay? So the temperature is going up. And let's think about what the problem is asking for. What will happen to the size? Well, remember, size is like volume, the amount of space an object takes up. So we're looking at the relationship between temperature and volume. Well, if temperature goes up, we know temperature and volume are directly related, so volume must also increase. Number two is a quantitative volume temperature problem. Here it tells us the volleyball starts at a volume of 2 liters and a room temperature at room temperature, 300 Kelvin. The sauna is at 400 Kelvin. What is the final volume after we put that volleyball in the sauna? Well, we know the equation from before. V1 over T1 equals V2 over T2. So let's go ahead and plug in our values. In V1, our starting volume is our volume of 2 liters. This is for units for volume. 2 over 300 Kelvin is my starting temperature. Equals V2, well, I don't know that. That's my final volume, that's my unknown, over my final temperature, which is 400. So I'm going to go ahead and cross multiply here. I'm going to butterfly across. 2 times 400 gives me 800. 300 times V2 gives me 300 times V2. Solve for V2 by dividing by 300 on both sides. So I'm left with 800 over 300, which gives you a final answer. V2 equals 8 over 3 liters. So that's an example of a qualitative and a quantitative problem. Check them again. If there's anything that you're not sure about, watch this part of the video again. Otherwise, move on to the next two problems to attempt them by yourself for practice. Pause the video now to attempt these two problems by yourself. When you're finished, check your answer by hitting play. So for number one, what will happen to the size of the volleyball if you put it in an ice bath? Well, ice bath means temperature is going down. Size means volume. So the volume is going to go down too because they're directly related. So volume would decrease. Number two, quantitative problem. The volleyball starts at a volume of 2 liters at 300 Kelvin. The ice bath is half of room temperature, which we learned was 300. So that's 150 Kelvin. So the setup for this would be 2 liters over 300 equals your V2 over 150. You can butterfly, cross multiply, or realize that to go from 300 to 150, you divide by 2. So to go from 2 to V2, you also have to divide by 2, because they're directly related. So your V2 is going to equal 1 liter. If you feel confident with these problems, move to Exit Ticket on your iPod or Chromebook and answer the questions that follow.